guys! Welcome again sa ITS, Information Technology Skills. We provide tutorial videos about computer programming. So kung bago ka sa channel na to, don't forget to subscribe at i-hit yung notification bell para ma-notify ka sa mga tutorial videos about computer programming. So guys, ang pag-uusapan natin ngayon is the priority scheduling on CPU scheduling algorithm. So first muna natin i-discuss is what is priority scheduling. Each process is assigned a priority, and the CPU scheduler selects the process in the ready queue with the highest priority to execute text. So, take note, in priority scheduling, meron siyang ibibigay ng mga numbers for each processes. And the lower the number, the higher priority. So, in priority scheduling, we have the non-preemptive and preemptive style. So, ulitin ko lang ulit. For non-preemptive, ito po yung mga CPU na hindi napuputol. We have the N and P, no putol. For preemptive, may putol. So we have the word P. We have the first example for non-preemptive priority scheduling. So we have here the table. If you're going to observe, wala po siyang arrival time. So, big sabihin, itong apat na processes na to, dumating sabay-sabay. And these are their CPU bursts. So, the arrangement of the priority, we have 3, 2, 1, and 4. So, take note ulit guys, the lower the number, the higher the priority. So, let's create the Gantt chart. So, at time 0, dumating itong apat na processes na to. Sabay-sabay sila. So, ang gagawin ni operating system, titignan niya kung sino yung pinakamataas ang priority. So, ibig sabihin, titignan niya yung pinakamababa ang number. So, on these 4 processes, P3 has the lowest number. Siya po yung merong 1 na priority. So, ibig sabihin, siya yung pinakaunang ipaprocess. So, pupunta siya ngayon sa Gantt chart. Ibig sabihin, ipaprocess na siya ni CPU. So, we have the CPU burst na 6. So, 0 plus 6, that is 6. Matatapos si P3 at time 6. Then, the CPU will look for the next priority or CPU na gagawin niya. So, yung pinakamababa or yung sunod dun sa 1. So, ang sunod dun sa 1 is the priority or the CPU na merong priority na 2. So, that is P2. So, P2 will go dun sa CPU natin. So, lalagyan natin siya sa Gantt chart. Ngayon, matatapos si P2 at time 9. So, paano naging ganon? We have 6 plus the CPU burst na 3. 6 plus 3, that is equal to 9. So, tapos na tayo kay P3 and kay P2. Ang next na priority is yung 3. Dito tayo sa priority nakatingin. So, ang may 3 na priority is si P1. So, ibig sabihin, si P1 naman ang pupunta ngayon sa Gantt chart. Meron siyang CPU burst na 17. So, matatapos si P1 at time 26. So, 17 plus 9, that is 26. And lastly, yung merong pinaka-last na priority, sa kalap naman nito guys, siya daw yung pinaka-last. Hindi siya importante sa magkakaibigan. Oh my God. Okay, well anyway, so we have P4. So, yung P4, siya yung next dun sa CPU. Meron siyang CPU burst na 2. Okay? So, matatapos siya at time 28. 26 plus 2, that is 28. Now, if we're going to compute the turnaround time, that is time finish minus arrival time, for P1, natapos siya at time 26. And ang arrival time niya, kung titignan natin dun sa table, wala siyang arrival time na nakalagay. So, we're going to consider na 0. Sabay-sabay sila at time 0. So, 26 minus 0, that is 26. Then, for P2, natapos siya at time 9. Arrival time at 0. So, that is 9. P3, 6 minus 0, that is 6. P4, 28 minus 0, that is 28. So, if we're going to compute the average turnaround time, we're going to add lahat nung na-compute natin na turnaround time divided by number of processes, that is 4. So, we have here 26 plus 9 plus 6 plus 28 divided by 4, that is equal to 17.25. The next, the waiting time. So, for the waiting time, we have the turnaround time minus the CPU burst. For P1, the waiting time is 11. So, paano naging 11? So, we have the turnaround time na 26 minus the CPU burst na 17, that is 11. For P2, the turnaround time is 9 minus 3 na CPU burst, that is 6. P3, 6 minus 6, that is 0. P4, 28 minus 2, that is 26. And if we're going to compute the average waiting time, add din natin lahat na na-compute na waiting time divided by number of processes, that is 4 again. So we have here 11 plus 6 plus 0 plus 26 divided by 4, that is equal to 10.75. Another example for non-preemptive priority scheduling. So we have here a table. So ito lang din yung kanina, nilagyan lang natin siya ng arrival time. So ngayon, ang arrival time natin for P1, that is 0, P2, 1, P3, 2, P4, 3. So kapag nagkakaroon kasi ng arrival time, nababago din yung arrangement. So paano nababago yung arrangement ng execution? So let's say we're going to create a Gantt chart. At time 0, iisa pa lang yung process na dumating, which is si P1. Although, the priority for P1 is 3. Pero wala nga namang maghihintay si CPU ng another process na titingnan niya kung sino mas mataas na priority, wala naman siyang ginagawa. So, ibig sabihin, ipaprocess na niya si P1 para hindi sayang yung time, okay? So, pagka-process kay P1, matatapos siya at time 17. Kahit 3 yung priority niya dahil wala naman siyang kasama, nag-iisa siyang dumating at time 0, siya mapaprocess. Okay? So, tapos na siya at time 17. And, nung time 1, dumating si P2. Meron siyang priority na 2. At time 2, dumating si P3. Meron siyang priority na 1. And at time 3, dumating si P4. Meron siyang priority na 4. This is the time na titignan na ni CPU yung priority. Kasi, habang napaprocess si P1, meron ng 3 processes ang pumila sa labas. P3, ibig sabihin, siya na yung next na i-execute. Okay? So, execute siya dun sa Gantt chart or dun sa CPU. Meron siyang CPU burst na 6. So, 17 plus 6, that is 23. Then, next na priority, that is 2. So, sino yung may priority na 2? Si P2. Okay? So, si P2, meron siyang CPU burst na 3. So, 23 plus 3, that is 26. Then, lastly, si P4. Okay? So, pupunta na rin sa wakas si P4 sa CPU. Ilalagay na natin siya sa Gantt chart. Meron siyang CPU burst na 2. 26 plus 2, matatapos siya at time 28. So, if we're going to compute the turnaround time, ganun din siya guys. Kunin natin kung kailan siya natapos and the arrival time. Okay, so for P1, natapos siya at time 17. And ang arrival time niya is 0. So, 17 minus 0, that is 17. For P2, natapos siya at time 26. And the arrival time is 1. So, that is 25. P3, 23 minus 2, 21. P4, 28 minus 3, 25. Then let's compute the average turnaround time. We have 17 plus 25 plus 21 plus 25 divided by 4, that is equal to 22. The next, we have the waiting time. Turnaround time minus the CPU burst. For P1, we have the turnaround time na 17 minus the CPU burst na 17, that is 0. P2, 25 minus 3, that is 22. P3, 21 minus 6, 15. P4, 25 minus 2, 23. So, if we're going to compute the average waiting time, we have 0 plus 22 plus 15 plus 23 divided by 4, that is equal to 15. The next example for non-preemptive. We have 5 processes. Then, these are the arrival time. We have here the CPU burst and of course the priority. So, kung titignan naman natin ngayon dito, meron tayong dalawang priority. So, paano kapag gano'n ang nangyari? So, let's try to create the Gantt chart. So, at time 0, meron tayong isang process na dumating, that is si P1. Although the priority is 4, dahil nag-iisa lang naman siya, wala nang titignan si CPU or operating system na priority. Para hindi sayang yung time, ipaprocess niya na agad si P1. So, we have here the CPU burst na 8. So, ibig sabihin, at time 8, matatapos si P1. So, if we're going to observe, at time 8, meron tayong 3 processes na dumating. So, we have process 2 na dumating at time 3. We have process 3 na dumating nung time 4. Then, process 4 na dumating nung time 6. Then, at this point, titignan ngayon ni operating system kung sino ang may highest priority para yun yung next niya na i-execute. So, dito, punta tayo dun sa priority for the 3 processes. So, si P3 ang merong pinakamataas na priority. Siya yung may 1. So, execute ngayon si P3. Siya ngayon yung pupunta sa CPU. Okay, so matatapos si P3 at time 13. So, paano naging ganon? So, we have 8 plus 5 na CPU versus ni P3, that is 13. So, tanggalin na natin si P3 dun sa table. Then, we have another process na dumating. That is P5. Dumating siya at time 10 during the execution or habang napaprocess si P3. So, ngayon, meron tayong 3 processes na nakapila. We have P2, P4, and P5. Titignan ngayon ni CPU kung sino yung may pinakamataas ang priority. So, ang next na may pinakamataas na priority is si P4 at saka si P5 because meron silang priority na 2. Pareho sila. Pero sino kaya ang unang i-execute ni CPU or ni operating system? So, dahil pareho sila ng priority, that is 2, magbe-base ngayon si operating system dun sa arrival time. So, ang unang dumating is si P4. So, si P4 ngayon ang ma-execute. So, matatapos si P4 at time 16. So, paano naging 16? That is 13 plus 3, that is 16. So, tanggalin na natin ngayon si P4. Then next, of course, another process na mayroong priority na 2, that is P5. So, si P5 ang next dun sa CPU. So, si P5 naman matatapos at time 18. Kasi meron siyang CPU verse na 2 and 16 plus 2, that is 18. Then lastly, we have P2. Yun na yung pinakalas na pupunta kay CPU. So, for P2, matatapos siya at time 22. So, meron kasi siyang CPU verse na 4 plus 18, that is 22. Then now guys, we're going to compute the turnaround time. So, for the turnaround time, meron tayong time finish minus time arrival. For P1, natapos siya at time 8 and the arrival time is 0, that is 8. P2, natapos siya nung time 22, arrival time niya is 3. So, 22 minus 3, that is 19. P3, 13 minus 4, 9. P4, 16 minus 6, that is 10. Then P5, 18 minus 10, that is 8. So, if we're going to compute the average turnaround time, we have 8 plus 19 plus 9 plus 10 plus 8 divided by 5, that is equal to 10.8. Then let's compute the waiting time. We have the turnaround time minus the CPU burst. For P1, the turnaround time is 8 and the CPU burst is 8. So 8 minus 8, that is 0. P2, 19 minus 4, that is 15. P3, 9 minus 5, that is 4. P4, 10 minus 3, that is 7. P5, 8 minus 2 equals 6. So let's compute the average waiting time. We have 0 plus 15 plus 4 plus 7 plus 6 divided by 5, that is equal to 6.4. So, ngayon naman guys, punta naman tayo dun sa preemptive priority scheduling. So, we have here a table. So, meron tayong 4 processes, the arrival time, the CPU burst, and of course, the priority. Now, let's create the Gantt chart. So, let's say, so at time 0, meron tayong isang process na dumating, that is P1. And the priority for P1 is 3. So, dahil wala pa namang ibang process, i-execute yan ni CPU. So, ma-execute siya. But, at time 1, dumating si P2. Ngayon, P2, meron siyang higher priority kasi ang priority niya is 2. So, ibig sabihin, mapuputol si P1. Ang next na execute ngayon ni CPU is si P2 kasi mas mataas yung priority niya. So, lalabas si P1 and papasok ngayon si P2. Pero before that, i-minus muna natin kung ilan yung remaining time ni P1. So, meron siyang CPU burst na 17. This is the original CPU burst minus number of time na na-process si P1. So, na-process siya ng 1 millisecond. So, 17 minus 1, that is 16. Ngayon, ma-execute naman si P2. So, si P2, ma-execute siya. But at time 2, meron ulit tayong isang process na dumating. Si P3. And ang priority ni P3 is higher na naman. Meron siyang 1 na priority. So, ibig sabihin, mapuputol ulit si P2 and si P3 ang i-execute. So, before that, kunin ulit natin yung remaining time ni P2. So, paano natin kunin? We have 3, the original CPU burst, and the number of time na na-execute si P2. Paano natin malalaman kung ilan yung number of times na-execute si P2? Natapos siya nung time 2, pero pumasok lang siya nung time 1. So, 2 minus 1, that is 1. Then, we have here 3 minus 1, that is 2. We have 2 na remaining time kay P2. So, ngayon, ma-execute si P3. At time 3, meron si P4. Pero, ang priority ni P4 is 4. Mas mataas pa rin si P3. So, dire-diretsong matatapos si P3. Hanggang kailan matatapos si P3? Matatapos siya at time 8. So, paano nangyari yun? We have 6 na CPU burst and yung first na pasok niya, that is 2. So, 6 plus 2, 8. So, dahil meron na tayong 3 processes na nakapila, P1, P2, and P4, titingnan ngayon ni CPU kung sino yung pinakamataas ang priority dun sa naiiwan na processes. So, pinakamataas ng priority, we have P2. So, ibig sabihin, si P2 ang i-execute niya. So, tanggalin muna natin si P3 para hindi siya panggulo. Okay? So, P2, pupunta siya ngayon kay CPU. Ilalagay natin siya sa Gantt chart. Ilan yung remaining time ni P2? We have 2. So, 2 na remaining time plus 8, matatapos siya at time 10. So, tanggalin natin si P2 dun sa table. Dun sa dalawang naiiwan na process, we have P1 as the next priority. Okay? So, P1 ngayon ang pupunta sa CPU and ma-execute siya hanggang 26. Paano naging 26? We have the remaining time na 16 plus 10, that is 26. And lastly, of course, P4. Natatapos ngayon si P4 at time 28. So, we have 26 plus 2 na CPU burst ni P4, that is 28. So, let's compute for P1. Tapos siya at time 26. Arrival time is 0, so that is 26. P2, we have 10 minus 1, kasi natapos siya time 10. Arrival time is 1, so that is 9. P3, we have 8 minus 2, that is 6. P4, 28 minus 3, that is 25. So, if we're going to compute the average turnaround time, we have 26 plus 9 plus 6 plus 25 divided by 4, that is equal to 16.5. Then, let's compute the waiting time. So, we have here the P1, 26 minus 17, that is 9. P2, 9 minus 3, that is 6. P3, 6 minus 6, 0. P4, 25 minus 2, 23. So, the average waiting time is 9 plus 7 plus 0 plus 23 divided by 4 is equal to 9.5. Another example for preemptive priority scheduling. We have 5 processes, the arrival time, and the priority. So, dito, ito lang din yung nandun sa non-preemptive natin, yung merong dalawang magkapareho ang priority. So, let's create the Gantt chart. At time 0, isa lang ulit yung dumating na process, that is Q1. So, ibig sabihin, i-execute na siya agad. Although the priority is 4 kasi wala naman siyang ibang comparison. Okay? So, meron siyang CPU burst na 8. But, at time 3, dumating si P2. The priority of P2 is 3. This is higher than the priority ni P1 na 4. So, ibig sabihin, lalabas si P1. Then, papasok si P2. So, ibig sabihin, let's compute the remaining time ni P1. So, the CPU burst na 8, that is the original CPU burst, and the number of time na na-execute siya ng 3 milliseconds. So, meron siyang remaining time na 5. Ngayon, na-execute or papasok ngayon sa CPU si P2. Lalagay natin si P2. At time 4 kay P2, dumating si P3. The priority ni P3 is 1. Higher than P2 na meron lang siyang 3 na priority. Ibig sabihin, lalabas ngayon si P2. Then, papasok si P3. So, lumabas si P2, kunin natin yung remaining time niya. The remaining time ni P2, we have 4. The original CPU burst minus 1 kasi natapos siya or naputol siya nung 4 and pumasok lang siya nung 3. So, 4 minus 3, that is 1. So, that is the number of execution niya. So, 4 minus 1, we have 3 na remaining time. Ngayon, napaprocess si P3. So, ma-execute ngayon si P3. Matatapos si P3 at time 9. Dun sa gitna, at time 6, dumating si P4. The priority of P4 is 2. Okay, so, mas mataas yung priority pa rin ni P3, ibig sabihin hindi pa siya mapuputol. Kasi nga, siya yung higher priority. Natapos si P3 at time 9. So, dahil sa tapos na si P3, tanggalin na natin siya dun sa table. So, we have how many process na nakapila? We have 3 processes. Nakapila si P1, P2, and P4. P4. Meron siyang priority na 2. So, ma-execute siya ngayon. At time 10, dumating si P5. Ang priority ni P5 is 2. Same with P4. So, sino kaya ang i-execute? Si P4 or si P5? The answer is matutuloy or ko-continue pa rin yung execution ni P4. The reason is pareho lang din naman sila ng priority. So, tatapusin si P4. Matatapos si P4 at time 12. So, paano naging ano? We have 3 plus 9 that is equal to 12. So, tanggalin na natin si P4 dun sa table kasi tapos na siyang ma-execute. Meron tayong P1, P2, and P5 na processes. And these are the priority. So, titingnan ulit kung sino pinakamataas ang priority. So, we have P5. So, si P5, execute na siya ngayon. Matatapos siya at time 14. Because meron siyang CPU burst na 2. Then, tanggalin ulit natin siya sa table. We have 2 remaining process. So, we have P2 na next na execute because meron siyang 3. So, ma-execute si P2 dun sa CPU, matatapos siya at time 17. So, paano naging 17? We have 14 plus 3 na remaining, that is 17. Then, lastly, we have P1. So, matatapos si P1 at 22. 17 plus 5 na remaining ni P1, that is 22. So, compute natin yung turnaround time. So, P1, natapos siya at time 22. Although na-execute na siya dito sa una, pero ito yung time finish niya dun sa end. So, 22 minus 0, that is 22. P2, natapos siya at time 17, although na-execute din siya dito sa una. So, 17 minus 3, that is 14. P3, 9 minus 4, that is 5. P4, 12 minus 6 equals 6. P5, 14 minus 10, that is 4. So, if we're going to compute the average turnaround time, we have 22 plus 14 plus 5 plus 6 plus 4 divided by 5 is equal to 10.2. Then next, we have the waiting time. P1, the turnaround time is 22 minus the burst time, that is 8 equals 14. P2, 14 minus 4 equals 10. P3, 5 minus 5 equals 0. P4, 6 minus 3 equals 4. P5, 14 minus 2 equals 12. So the average waiting time is 14 plus 10 plus 0 plus 4 plus 12 divided by 5 is equal to 8. So those are the examples of preemptive and non-preemptive priority scheduling. Kung gusto mo pa matuto about other CPU scheduling algorithms, click on the video na nakikita mo dyan sa screen mo. And of course, don't forget to like this video kung nakatulong to sa inyo. Bye!